My name is Tulu Tyro. I'm from Pint of Science, Nottingham. I'm here today with Dr. Silke Weinfurtner from the School of Maths here at Nottingham. And we're actually in her lab here at the School of Physics at the University of Nottingham. And I'm here to ask you a couple of questions, but one of them being, how exactly did you get into science?
Okay, so that was in the last year at school, so I was set to become an architect until we had, in physics, we studied gravitation, and we studied Newtonian gravity, and so I was struggling to understand that, and I went to my teacher and I asked him a few questions, and he said, actually there is a more complete theory of gravity, which is general relativity, and he recommended some books, and I started reading, and then I really fell in love with this theory and understood that if I want to understand some deep details about that, I have to go and study physics. So that has changed everything, and yeah, that's why I'm here today.
Oh wow, okay, quite a difference and quite a journey to get to where you are. So why do you feel your sort of area of expertise in science is relevant to today's society?
It's clearly fundamental research. There is a wider question, how you combine two of the most fundamental theories, that's general relativity and quantum field theory, quantum theory. And so that's a very difficult problem, and I'm working on sort of intermediate step towards that, which is very much concerned with how a quantum gravity theory would connect to the real world, what observable consequences it has, and also how universal and how robust some of these processes are, which are predicted in this interface between gravity and quantum physics. And so this is where my line of research falls in, to make some small progress towards this extremely important and fundamental question.
It's really interesting. What would you say is the most unexpected thing you've learnt along the way?
I started actually got an undergraduate degree in engineering, and then I went to the university and studied theoretical physics. And then I went to do my PhD in applied mathematics. And now I'm working together with civil engineers again, doing very hands-on things. So I have changed my directions so many times. So I think I never know what will I be doing in 5 years or 10 years. And I think it's also because of the people you're working with. They change your directions. And I think that's quite interesting, this uncertainty. So that keeps this whole, makes this job very interesting, actually. Yeah.
There's been many sort of approaches to try and encourage a lot of women to get more into STEM subjects. So why do you think there's a bit of a barrier in terms of women going into STEM subjects, and indeed your area of physics?
It's hard for me to understand that, because I'm very much driven by my passion, my interest. So I'm not looking so much outside, more inside what I want to do. But perhaps for many people it's also more to get the idea, also women work in this field, to maybe this makes a difference. I just think like for every woman or young girl in the UK and everywhere, as long as you can do it, you should go for it. And I can just say that my experience has been very positive. I had many people, many male supervisors, which helped me tremendously. That didn't make a difference between me being a woman or a man. So I would say that now things have changed, and if you're a woman, you want to go for it, this is a great job, and there are many opportunities for women, especially also in the UK now.
Antonella, why don't you tell us what this giant contraction is and what it's called?
So this is basically a small swimming pool where we make some water flowing and drain into that hole in the middle. So also a giant sink if you prefer. And the idea behind this is to reproduce some effect that arises near a black hole in space, but in a much safer environment, I would say.
So the hole in the middle of the swimming pool, that is effectively simulating the black hole, isn't it?
So what we're interested in is how small waves on the surface of the water propagates on this water which is flowing and falling into this hole. And the reason why it's related to a black hole is quite simple to grasp. It's simply because if you send a wave toward the hole, the wave goes down and the speed of the flow is too fast, so the wave cannot climb back and it's trapped sort of forever inside that hole, which is basically what a black hole is. And from this we can extract the information and try to reproduce some effects. So for example, how a black hole can be used as amplifier, restoring more energy than you send in by sending a wave, or some weird effect like this, we can reproduce them in this specific system.
So we're now here with Tom, who is the master student in Dr. Silke's lab, and he's going to tell us all about this 3D printer.
So this printer can be used to make all sorts of things. We use this plastic kind of filament thing, and you can go into some programs on the computer, and you can say, I want to print this slope. You can print things like this. You can print things like this. You can print basically whatever you want, whatever will stand up. So currently, what it's doing is printing something exactly like this. This is a little ramp. We've got a little obstacle. Now we put this not in a flow a bit like that, but not spinning. We have a straight flow, and we put these in, and we have another one back to back like this. And basically, the water goes over this, and as the water goes over it, it changes speed. It creates a sort of certain geometry in the water that we can design it. So we can design it to make it look like a black hole, even in a straight flow, without a big hole in the middle, basically by changing the speed of water. And we can design just how to change the speed of water by designing this to be an exact shape we want.
So we're here now with Lucinda, and she's going to tell us a bit about some work that she's going to be doing with this laser over here. So tell us, what is this laser? What are you going to be doing with it?
So to measure the free surface on the tank of water, we need to project a light sheet. We want like just a one-dimensional light sheet that will span like a long area. And
this, is on top of the water in the big pool we've just seen.
Yeah, obviously there's dye particles in the water that make it this green colour, and when that's illuminated with the laser, they'll absorb the light and fluoresce, and then you can image them, and that shows you, so you can pick out the free surface where the like peaks in the intensity are. So obviously the laser is a green laser, and it's gonna be a thin beam. So we had to find a lens which is going to split that into the sheet.
Oh, 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 oh.